All right, section 10.2 is all about prisms. We're going to find the surface area and the volume of a prism. So this first part of the slide here looks exactly the same as the last video. It just defines a polyhedron again. It's a solid bounded by polygons, which are the faces, that enclose a single region of space. So as long as you have a shape with flat edges, you're good to go. If you have anything with circles, these are not polyhedrons. Okay, let's first define surface area, because what this whole unit's going to be about is we're going to find surface area and volume of different three-dimensional shapes. Like I said, today is prisms. So just in general, the definition of surface area is total area on the outside of the figure, which, if you want to think of it this way, it's the amount of material it takes to make a hollow object. Now I realize that's very hard to read, so I'm actually going to scoot that definition up right above. So there you go. The total area on the missed part of it. On the outside of the figure, the amount of material. So we talked about area. If you were given a square, you'd find the area would just be the amount of space that two-dimensional shape takes up. Well, now we have a bunch of different two-dimensional shapes making up a figure. So we call it surface area because it's a three-dimensional object. So there's a couple ways you can calculate surface area. Number one, you can find the sum of the areas of the faces. So you could find the area of each individual face and add them all up. That's one option. Or number two, what we're going to spend a lot of time doing is just use a formula. So this unit again will be a lot of formulas. So like I said, today's all about prisms, and the definition of a prism is just two congruent parallel sides called bases. So that's what makes it a prism. And then we name it after its bases. So here you can see a few examples. You can see that this side here and this side down here, those are the bases. They're parallel to each other. They are the exact same shape. Therefore, it is a prism. So we would call that, you would name it by its base. So this base here, it's a five-sided figure, so it would be a pentagon. So that would be like a pentagonal prism, if you want the spelling. There you go, pentagonal prism. Here, our bases are flipped up a little bit. So we have, there's a base, there's a base. That is, each base is a hexagon, so it would be a hexagonal prism. Those are the two sides parallel to each other. And then here we have a triangle and a triangle. Those are your bases, so we would call it a triangular prism. Okay, now here's how you find the surface area of a prism. So you're going to have to find the area of some two-dimensional shapes. But the surface area equals 2b plus ph. Right here, b is your base area. So like I said, if I have a triangle and this is my base, I got to find the area of that triangle, multiply it by 2. And then I'm going to add to that the base perimeter. So we're back to that idea of perimeter. So if this was let's make it an equilateral triangle. So let's go like 7, 7, 7. The perimeter would be 21, so you'd have to find the perimeter and then multiply it by its height. Well, its height here, it's kind of weird because it's laying flat, but it would be this distance. Or in my pentagonal prism, this would be my height. Here would be my height in the hexagonal prism. So we got to find a few different things. So it's going to bring back a lot of those ideas, those things we talked about in Unit 9. So the surface area of a prism. So here is the formula again. This is the most basic prism. It's like a box. We would call this a rectangular prism if we're being exact, because our bases are rectangles. Now with this, our base could really be our base we'll just call the top and the bottom, because this one's kind of tough to see. It kind of just depends on the way it's laying, because you could call the left and the right side the bases as well, the front and the back the bases. So I'm just going to use the top and the bottom as the bases because that's the way it's laying. So we need the base area. So let's start with that. Big B. So here's our base. Like I said, I'm going to call it the top and the bottom. Those are my bases. So we got to find the area of that rectangle. Well, how do you find the area? Length, 9 times width, 7. So 9 times 7 is 63. So B, my base area, is 63. Now I need to find the base perimeter. So I still have my base colored in there. The perimeter is if you add up all the sides, so 9 plus 7 plus over here would be 9 inches plus, another 7 right there. So if you add all of that up, 9 plus 7 is 16, plus 9 is 25, plus 7 would be 32. And then the height of this box is going to be 3. Sorry. There we go. So we have everything we need. So to find the surface area, I take 2 times B. B was 63. Plus the perimeter, 32, times the height, which was 3. So that's going to be 126 plus 96. If you add that up, we get 222 inches squared. Because we're still talking area here, the A stands for area, we're still in whatever units squared. So another one here, the area of this prism. So you can see it right below the shape there, below the figure. It says make sure you can correctly identify which is the base. So you're looking for the parallel sides. So right here, this is parallel here to that. So those would be our bases. So it's like a prism that got turned on its side. That's fine. We can still find that. So when I find B, the area of one of my bases, I'm actually looking at this triangle that's facing me right now, because, like I said, it's like a triangular prism that got turned on its side. So to find the area of that triangle, you take 1/2 the base. It doesn't matter which one you call the base, but we'll go 16 times the height, 12. So 1/2 times 16 times 12 is 96. Then you got to find the perimeter of that base. So we have 12 plus 16, so we're sitting at 28 right now, but I don't know this distance here, so I'll do the Pythagorean theorem real quickly. A squared plus B squared equals C squared. So 12 squared plus 16 squared equals C squared, 144. Plus 16 squared, 256. Oops, not equals. Equals C squared. If I add those up, I get 400 equals C squared. If I take the square root of that, I get 20. So if I add up my perimeters, so 12 plus 16 is 28, plus 20 would be 48. So there's the perimeter of my base. Okay, now the height of the object, like I said, it's like it got turned on its side. So this part right here is actually the height. If I were to tip this the right side up, that would be how tall that figure is, that prism is. So my height is 10. So to find the surface area, we're going to take 2 times my base area, which is 96, plus my perimeter, which is 48, times 10. So 2 times 96 is 192, plus 480 gives me a total of 672 centimeters squared. So that's how you find surface area of any prism. Now, it could get difficult if you're dealing with a pentagonal prism, or a hexagonal prism, because you have your faces are regular polygons, which means you're going to have to do something like 1/2 the apothem times the perimeter to find the area of that. So it's going to bring back that whole idea from Unit 9 as well. So the next part of this here is volume. So volume is, just to define it, I'm going to go above it here, total space taken up by a figure. So that is what we call volume. So how do you calculate volume? There's only one way. Use a formula. I mean, there's multiple other ways that are way above the level of geometry, but we're going to use just a formula. So like I said, this whole unit is going to be just formulas all over the place. So how do you calculate the volume of a prism? Well, this one's much easier. You take B times H, where B is your base area, H is your height. So if you recall from just a couple of examples ago, we found the surface area of this rectangular prism would be the proper name. It looks like a box. The surface area was 222 inches squared. Using the same diagram, we can find the volume. So we still need our base area. So again, this is what we're calling our base. So 9 times 7 is going to be 63. And we need our height, which is 3. So the volume is going to be, I wrote 63 backwards. 63 times 3, which is 189 inches. Now that we're in volume, we're talking all 3 dimensions here. So our units are going to be cubed. So here we go, another example that we've already done. The formula to find the volume of any prism is still base times height, where B equals base area, H equals height, BH. So again, we talked about this kind of extensively before, but this is a triangular prism because it's like my triangle got flipped on its side. So we still need to find my base area, which is 1/2 times 12 times 16, which we already did, but we get 96. We found the base area already. The height of this thing, like I said, it's like it got tipped over. If I tip it right side up, that's my height, so it would be 10. So my volume is equal to 96 times 10, which is 960. This one would be centimeters cubed. So that is surface area and volume of prism. So the key is to make sure you can identify your base correctly, and then no matter which one you're doing, you have to find the area of that base, and then depending on which one you're doing, surface area or volume, you have a little bit more work to do or a lot more work to do. But that'll take care of section 10.2.